if we have a function from A to B, where A and B are finite sets, how many total functions can you make? Or how many total functions are there possible? So how are we going to come up with this answer? I'm instead going to do two examples, and from them we're going to extract the formula you use to figure out how many total functions there are from two finite sets. So let's go ahead and create two finite sets. Let's let A equal to 1, 2, and 3, and let's let B equal to, let's say, 1. Right? So how many total functions are there? Well, let's do the following. We know that we need to map every single element in A only once to something in B. So this means how many ways can we map 1? Let's just look at the 1 element here. How many ways can 1 be mapped to something in B? Well, the answer is once, because there's only one element it can map to, so it's going to be 1. Okay, then let's look at 2, right? How many ways can you map 2 onto something in B? And the answer is going to be once. You can only map 2 once onto B, or this would be a multiplication sign. Finally, let's have a look at 3. How many ways can you map 3 onto something in B? And the answer is going to be once. You can only have 3, 1. You can't have anything else map 3. Okay, why did I have a multiplication symbol? Well, because whatever 1 maps to, it doesn't care what the rest of the elements map to, so it's an and, right? 1 maps to 1, and 2 maps to 1, and 3 maps to 1. Whether 3 maps to 1 does not affect what 2 maps to or what 1 maps to. So in this case, we find the total number of functions is going to be 1. The only possible function you can create here is going to be 1, 1, 2, 1, and 3, 1. This is the only possible function. What if instead we increased the size of B by another element? So B now has 2 elements. How many functions can we create now? Well, let's start by looking at the first element. We know 1 has to map to something in B only once. 1 cannot map to 1 and 1 cannot map to 2 at the same time, but those are our 2 possibilities. So what does this mean? We can have 1, 1, or we can have 1, 2. We can't have both at the same time. And of course, there's only a possibility of this being once and this being once, so this is going to be an addition sign. This can happen once, or this can happen once. So we add the 2 possibilities up. So there's 2 ways to map 1. Similarly, how many ways can we map 2? Well, it's going to be 2, 1, or 2, 2. So that's going to mean that you have 1 possibility of mapping it to 1 and 1 possibility of mapping it to 2. You add those 2 up, you have 2 possible ways you can map 2. Finally, let's do 3. How many possible ways can we map 3? Well, you can have 3, 1, or you can have 3, 2. So this means you can only map 3 to 1 once and 3 to 2 once, and you can't map them at the same time. You have to have distinct functions to map it. So there's 2 ways to map 3. And of course, from the previous example, we know that there's going to be a multiplication symbol between all of these, because whether we map 1 to 1 or 1 to 2 doesn't affect what 2 maps to 1 or 2 maps to 2, and that does not affect whether 3 maps to 1 or 3 maps to 2. These are independent of each other. So it's a multiplication symbol. What do we find? Well, it's going to be 2 times 2 times 2, which is going to be 4, 8. There's 8 possible functions you can create between these 2 sets from A to B. Now let's really increase our B. How many possible functions can we have when these are our 2 sets? Well, let's look at this again. What can we map 1 to? Well, 1 can be mapped to 1 in B, 1 can be mapped to 2 in B, or 1 can be mapped to 3 in B, or 1 can be mapped to 4 in B. So 1 cannot be mapped to both of these at the same time. It has to be one of these 4, cannot be more than one of these at the same time by our definition of a function. So note there's 1 possibility here, 1 here, 1 here, 1 here, and we add them up because they cannot happen at the same time. So we have 4 ways of mapping 1 onto B. Similarly, you're going to find that there's 4 ways to map 2, and 4 ways to map 3, because you just replace the 2 here. And we find that 2 can only be mapped in 4 different ways, and similarly for 3, and we know that they are independent of each other. Mapping a 1, a 2, and a 3 don't care. You can map 1 to 1 and 2 to 1, and they don't affect each other. Or you can map 2 to something else. That's not going to affect what 1 maps to, right? So because they are independent, it's a multiplication. What do we find? It's going to be 4 times 4 times 4, which is going to be 4 times 4 is 16, times 4 is 64. So there's 64 possible functions you can create with these 2 sets. Let's try one more example. This time I've kept b the same, but I've changed our a. A only has 1 and 2. So what do we know? Well, we know 1 can be mapped in all of the following ways. We can map 1 to 1 in b, or we can map 1 to 2 in b, or we can map 1 to 3 in b, or we can map 1 to 4 in b, right? Of course, this one is not the same as the one here. This one is the one in b. This 2 is the 2 in b. Don't forget that. So there is obviously 4 possibilities here. 1, 1, 1. We add them together. We get 4 possibilities to map 1. Similarly, we're going to get 4 possibilities to map 2 if we just want to replace these all with 2's. There we go. We find that there's 2 possibilities to map 2's. Once again, multiplication. We find that there are 16 ways that you can create functions using these 2 sets going from A to B. Okay, so we've done quite a few examples, and we've computed how many possible functions you can have in each example total. So let's go ahead and have a quick overview. We found the total number of possible functions for this case up here is going to be 1 times 1 times 1, right? There's only one possible way you can map 1, one possible way you can map 2, and one possible way you can map 3. So it's going to equal to 1. What do we find when we increased b to 2? Well, we found that there's 2 possibilities to map 1, 2 possibilities to map 2, and 2 possibilities to map 3. And we found the answer here was 8. Then when we really increased our b, we found that there were 4 possibilities to map the first element, and 4 possibilities to map the second element, and 4 possibilities to map the third element, which we got here was 64. And finally, here when we just kept b the same but decreased a, we found that there were 4 ways to map the first element and 4 ways to map the second element, so we got 16. Now, what do we notice here? Well, what you should notice here is that the number of multiplication signs, right? We have 3 multiplication signs here, is equal to the number of elements in our A. The number of the number of elements, or the number of numbers we're multiplying is going to equal to the number of elements in our A. So we notice that we have 3 multiplied here, we have 3 elements in A. We have 3 numbers multiplied here, we have 3 numbers in A. Similarly here, A has gotten smaller, so we're only multiplying 2 numbers, which should match our 2 here. Then, what do we notice? Well, we notice the actual numbers themselves, right? 1, 2, 4, and 4 are actually equal to the number of elements in our B. So B only has 1 element, so each of these is going to be 1. B here has 2 elements, so it's going to be 2. B has 4 elements, so we're going to get a 4. And B has 4 elements, so we're still having 4s. So what does this mean? This means that the total number of functions between 2 finite sets is going to be the size of A. So in this case, the size of A is 3, so 3 times, or sorry, let me restart that. The total number of functions something can have is going to be the size of B, so in this case we have 1, multiplied by itself by the size of A. So as we could see here, this is equal to 1 to the power of 3. This is going to equal to 2 to the power of 3. This is going to equal to 4 to the power of 3. And this is going to equal to 4 to the power of 2. We notice that the power is going to be the size of A. So however big our A is, A has 3 elements, so it's to the power of 3 here. A has 2 elements, so it's to the power of 2 here. And then the other thing we notice is going to be, of course, that the base of our power, 1, is going to be the size of b. So we find that this is 1 because b only has 1 element, 2 because b only has 2 elements, 4 because b has 4 elements, and 4 because b has 4 elements. So that is what we find here, and this pattern is going to be true for all finite sets. So what is our conclusion going to be? So we find that when we have the size of a and the size of b, the total number of functions is going to be m to the power of n, where n is the size of a and m is the size of b.